Here we are in 2015 with a geometry class. They have recorded very few, if any. Have you recorded any of these?
No, I think so.
Okay, so we have Michaela, Lauren, Carly, Sophie, and Sarah. And we're in the first section of Chapter 10, Developing Formulas, so this is going to feel like an easy day. And so with the warm-up, your answer for number 1 is?
29.
And number 2 is?
28.
Or if you're at home, pause the video and try this yourself. Number 3?
48.
Or if you're at school watching this as you are moving along in geometry, right? Today we're going to develop and apply the formulas for the areas of triangles, which we've done before. Who feels confident already in developing the formula for a triangle area? And special quadrilaterals. So, and then we'll solve problems involving perimeters and areas of triangles and special quadrilaterals. So who here has done a tangram? Have you ever had those plastic pieces of different shapes and you fit them together to form designs? That's what this is kind of showing you. It's an ancient Chinese puzzle, and they make these games for kids. I actually have one of these games over in the classroom, if ever you want to play it. They'll give you a design they want you to try to copy using the plastic pieces. So it's not always a square that's being made, but the pieces can be rearranged to form different shapes. And the interesting thing about that is when you put the pieces together, you could like take two different, you could take a rectangle and a triangle and make what? A parallelogram or a trapezoid. Okay, so there's different other figures that we're really familiar with that could be made by combining some of the basic figures, right? The area of any figure, of course, would be the combined area of all the little different parts. So this is looking rectangular to me. It looks like a square up on the board. But if I knew the area of this triangle, the area of this triangle, this and this, you know, how would I find the area of the entire region? Add. So you just add all the different little areas. It's a sum of the smaller parts, right? The area of an entire composite figure would be the sum of the non-overlapping parts. So you know the area of a rectangle is base times height. And what must height always be? Height in geometry is always, show me with your arms, perpendicular. It's always perpendicular. Does it have to be up and down? Does height have to be up and down? No, exactly. So it just must be the perpendicular distance from the base to the opposite, depending on the figure, the opposite side or the opposite vertex. So we can see when we look at this, what is this shape here? Actually, oh, okay. If we look at the darker shape in here, it's a parallelogram, isn't it? If we cut the triangular piece off the left side and bring it over here, what shape do we actually have? A rectangle. You could do that with any parallelogram. You could cut a triangle off of either end. We could have cut it off of here too. See this, right? Straight down here. From this vertex perpendicular straight down to the opposite base. And we could have brought that triangle to the other left side. So a parallelogram has the same area equation as a rectangle because a rectangle is a parallelogram. The thing about rectangles that makes them easy is that the height and base form two sides, right? But in a traditional, this type of parallelogram where you don't have 90-degree angles, the height is never a side. So that kind of tricks up kids when they're younger. Doesn't trick you guys up though, right? No. Okay. So remember that rectangles and squares are also parallelograms. Again, they have 90-degree angles for their sides. So the sides themselves are bases and heights. So they have the same formula for area. Area equals?
S squared.
For a square, S squared, because the base and height are both the same. Good. And perimeter for a square is?
4S.
Sounds like a ranch around here. 4S ranch. I think I've already said this. The height of a parallelogram is, actually 4S is passé with cell phones.
iPhone 4 and an iPhone 4S.
That's true.
What is the figure?
We just said this. Can you fill in the blank? The height of a parallelogram is measured along a segment
Perpendicular.
to a line containing the base. Good. This is very basic for you all, right? The perimeter of a rectangle with a base B and a height H. Who can explain why it is what you see here? Lauren.
It's how to say because there's two sides that are for that, and there's another two sides that are like this. So either way, you're just going to be multiplying two to both sides or to the total side.
Very good. So we have two bases that are congruent, two heights that are congruent. So we could just add the base and height and double it, or you could treat them separately. Two bases plus two heights. So let's find the measurements, both the area and I think we're finding both the area and the perimeter of this parallelogram. So look at this parallelogram. We're given two sides. We're given 11 and 34, two sides of it. So what are they suggesting we use to find the height? Which is why we warmed up with that, right? They did give us this dimension out here, which is not part of the parallelogram. But how does, I mean, it does help us form what here? A right triangle, right? And so what is, we have one side of this right triangle is 30, and which other side do we know? Good, the hypotenuse is 34, good. And so we're going to use that information to find this side, which is the height. I'm gonna pause while you do that. So Carly, how'd you set it up?
I subtracted 30 squared from 34 squared.
Okay, so she said 30 squared plus the height squared equals it. So she's subtracting 30 squared from 34 squared. That makes sense. And what'd you get?
I got 16.
And that was after you took the square root? Okay, good. Does everyone agree?
Yeah.
16. And so now that we have 16, that could be a height. It is a height of this parallelogram if we consider which side the base. Michaela?
The 11 side.
The 11. Why? How do you know?
Because it's perpendicular to the height.
Good. So 16 is perpendicular to this side, which is congruent to this side, right? So the base is 11, and the height is 16. So we substitute that in, and what did we get?
176 millimeters squared.
Good. I'm glad you're mentioning the units. You got to have the units, okay? Go ahead and answer this question. We're finding the height of a rectangle in which b equals 3, and the area is this awesome trinomial. Sophie's going to show you on the board here.
Wait.
I'm going to pause while you're getting ready. What did you say you were going to find?
The height.
Okay.
So you have to plug in 6 x
Equals 3 times h. Good. So what will you have to do? Okay. Isn't it such a beautiful trinomial they gave you there? And, well, actually, could you, I mean, have you found height? Well, doesn't h equal 2x squared plus 8x minus 2? Then I guess you found height in terms of x, right? Did they give us x? So are you able to find an actual value for height? Okay, so Sophie has it. I mean, we don't know what x is, so we're leaving our answer in terms of x. Other than you could, I guess, provide the units. Sophie's giving her signature. Like the fine artist, the math artist that she is. And what units would the height be in, everyone? Inches. So you could add that. 2x squared plus 8x minus 2 inches. Okay? Finding the measure of the perimeter when you know that the area of a rectangle is that, and you're given this diagram. Who wants to go up and show us? And if you're at home, you can do it on your own. So what are you going to do, Lauren? Tell us.
Well, we know the area, and we know one of the sides, so we have 79.8x squared minus 42. We know it's going to equal 21 times the height.
Good. 21 times h.
So then we can divide both sides by 21.
And she gets h equals 79.8 divided by 21. That's interesting.
So we
that she has. H equals 3.8x squared minus 2 centimeters. And now she's finding perimeter.
Okay, so perimeter is 2 times 3.8x squared minus 2, which is the height, plus 21, which is the base. So we have, if we simplify right here, we have 3.8x squared plus 19 times 2 is the perimeter. And if we multiply by 2, we get 7.6x squared plus 38.
And units?
Units is centimeters.
Awesome. And there is her fine signature. Good. Find the base of a parallelogram in which you have a height of that and an area of that.
So, I'm going to draw the parallelogram first.
Oh.
Why would you? I need a visual aid. Okay. And then the height is 56. And the area altogether is 28 yards squared. Wait, what?
Put a D there.
Okay.
Okay. And now you're going to find the base. If you are doing this on your own, pause, come back and see what she did. Okay.
Lovely signature.
And she was very curious about the fact that the base could possibly equal 1/2, and it does. It equals 1/2. Very interesting base here, Michaela. The area of a triangle, you have seen me do this before, cutting out 2 triangles and putting them together, and what do we get when we put 2 together?
Rectangle.
A parallelogram. So every triangle's area equals 1/2 of a parallelogram. Half BH. Now, I usually write that as BH over 2. The area of a trapezoid, we can do the same thing. We can clone a trapezoid. Remember? Let's grab one. Where can I grab a trapezoid? It must be down here somewhere. There's one. So we can make a trapezoid and clone it and rotate it. And when I put them together, what do we have? Okay, but so a trapezoid is half a parallelogram too. But when we put 2 trapezoids together, the bases have become longer, don't they? So we have 2 bases, which are the parallel opposite sides of a trapezoid, and base 1 plus base 2 gives us an entire base of a parallelogram times the perpendicular height. And then we take away 1, right, over 2. So your equation, do you guys feel pretty confident with that equation? Did you remember it before we just talked about it?
Something to do with adding the height.
Adding the 2 bases together?
Yeah, and
So
then dividing.
the shorter base in this case turns around and comes down and becomes part of a longer base with its opposite side. So you add the 2 bases together to get this side, multiplied by height, excuse me, and then divide by 2. Okay, so we're going to find the area of a trapezoid. Go ahead and do it if you're at home. Come back and check it out. Always begin with your plan. Write it down. And now we are going to substitute the known information, right? Area equals half of 8 plus 5, right? Times the height of 6.2. So 8 plus 5 is?
13.
And half of 13 is?
6.5.
So 6.5 times 6.2 is? 40.3 inches squared. Good. And then, of course, we can use this formula, just like we were doing with the other, to find anything. We could find a height, we could find one of the 2 bases, as long as we know the other base, and so on. Find the base of this triangle when given an area of 15x squared. So in geometry this year, your answers are not always going to be actual values. They may be a variable expression, like we saw earlier. Once again, start with your formula. And we know the area in this case. So the area is substituted for A. And we do not know one base. This, to me, is the most fun type. When you don't know one base, finding it is kind of tricky. And so what will you do? Next, there's a couple of options, but anybody tell me what you would do? Okay, you could divide 11 by 2 and you would have 5.5.
Multiply the other side.
5.5?
Yeah, multiply the other side by 2.
Multiply the other side by 2 is another option, and then divide it by 11. If you choose to multiply half to 11, you would have 5.5, which you could divide both sides by, right? So you have some options. Let's see, oh, they go ahead and divide both sides by 5.5. Or maybe they did multiply by 2 and then divide it by 11, I'm not sure. Oh, they tell you here, they divided by that. And so, because 11 over 2, the reciprocal is 2 over 11. It's kind of cool, the way they wrote it. And now when we subtract 23, we have our base, which is 19 millimeters. Don't forget your units, okay? And now you can try the lesson quiz. This is a 2-day lesson, so you're just doing part 1 today. Okay, so good job. So the first height is 9.1, and the perimeter is, this class is a spoiled class. The area of the trapezoid, look at that, we got 2 bases, and a height is, and the base is?
3x plus 2.
Let's see if you're right. Oh, what a smart class. We'll address this question, the rhombus question, tomorrow. This is a 2-day lesson, so here you go, 10.1, 10-1.1.